Parallel plates, using them to fire electrons. Sometimes they called them cathode rays because there was a stream of the beam of the electrons they were seeing as a ray. Done a lot in the history of science. But again, it just comes back to conservation of energy. The electric field energy that the electrons have when they're between the parallel plates gets converted to kinetic. Electric energy is Q times volts. Kinetic energy is always 1/2 mv squared. This particular version, we're looking for voltage. So it's going to be mv squared over 2q. You don't have to memorize the numbers. You can Google it or look them up if you're in the classroom. They're on the wall at the side, or find them on the internet. But the mass of an electron is 9.11 times 10 to the negative 31. The speed that I made up was 1 million. We'll need to square that, and divided by 2q. The charge on an electron is negative 1.6 times 10 to the negative 31. It's a scalar equation, so I should be a little bit particular and carry the sign through it. So I put the negative in since it's an electron. When I do the math on that, I get almost negative 3, negative 2.8. The sign on a voltage really tells you whether that battery would do positive work to a proton, or positive work on a positive charge, or positive work on a negative charge. Since we're getting a negative voltage, this is implying, in a way, it's telling us which way to wire the battery, or it's telling us that the battery did positive work on a negative charge. So it's okay that it's a negative number, but having said that, if you just said the voltage of the source is 2.8 volts, that would be fine as well. But the sign on voltage usually is communicating what you're doing positive work on, whether you're doing positive work on a positive charge